Okay, guys, so I continue in chapter 4 again for introduction statistic. So for now, I am working on section 4.2, measuring the strength of association with correlation. So remember that last time we did talk about, in 4.1, we did talk about first one is the chain, right? Chain of the scatter plot. Second one is the strength, and the third one is the linear or non-linear, or the shape. Right? So today we focus on like measuring the strength and actually like how can I say, is that going up or down? Is there anything that's can measuring that those two? Okay, so all right, so now this call is going to call correlation, is which is a letter R in this section, and we're gonna find and interpret the correlation coefficient, which is R. Okay, all right, let's move to the next page. So correlation coefficient is a number that measures the strength of the linear relationship, and its symbol is R, as I state in the previous one page, and it is always between -1 and +1. So what does that mean? R has to be from -1 to +1. All right, you cannot have an R like an R equal to -2. That is wrong. Okay, or R equal to 2. No, that is wrong. Something like that. And the -1, negative number present the downhill of the line, and the +1 present the uphill. Okay, so okay, let me clean this up. R value close to -1, right, or +1 is indicate a strong linear association. Okay, so someone like someone like R equal to -0.98 or 99 will indicate a strong linear association. Okay, but it's going down. Okay, and the other one is like R equal to, I'm gonna say 0.97, 0.98, something like that, right? It's will also be strong, but will going up, right? For the case that are equal to or close to 0, it will be weak association, right? Okay, so let's move to the next. Oh, okay, so as I state here, R values close to 0 indicate a weak association, right? Okay, so okay, so you can see in the first graph here, the line, the chain of the line is going up, right? and it's exactly lie, the point is exactly lie on a line. And so then that is a positive positive trend. So you should have R values is a positive. And also because the point is lying exactly on the line. So then R in here is equal to 1. Similarly, for the second graph, you see that the line is going down and exactly line on a line, and is so then it has to be a negative, but because it's exactly on the line, so then it should be equal to -1. So if I want to make an example for this, give me 1 second. I try to have, oops, another color. Maybe I will have this. If I have something like this, maybe I will use another one here. Right. Oops. If I'm gonna have something like this, right? Yeah. So the point is going up, right? And like exactly on the line. So then R still equal to 1. Okay. Remember that. Even though it's have different slope with this guy, but still is satisfied for two things. One is going up. Second thing is all the point is lying on the line. Then the R value just gonna be equal to 1. Okay, so that is the thing I want to tell you about this. Okay, so let's move to the next page. Okay, visualizing the correlation coefficient. For the first picture here, you can see that the R in here should be positive, right? Should be positive because the chain is going up, right? And because they close to each other, even though it's not gonna make exactly a line. So so I will say this should be around close around some number that's close to 1. But in here it also tells you that R equal to 72 because some point is spread out far away from the model line, right? Over here. For the second one, you are having the data is look like going up also. The trend is going up also, right? So R has to be greater than 0. But the thing in here is the data is like spread out. It's actually like not close to each other right here. So then the R in here is not, is far away from the 1. It's not. It's maybe go to the side of 0, and that's the reason why it have like R equals to 48. And I can say that it's because it's not have a strong relationship, right? See that? Okay. So similarly for the third one, you see that the data is spread everywhere, almost everywhere. I can even say like even though it's a little bit going off, a trend a little bit going up. I know that R has to be greater than 0 in this case, but the thing in here is it's almost spread out everywhere. So it's gonna go close to 0. So that's the reason why you have R equal to 0.19 in this case. Okay. So now let's move to the next page. Okay, computing the correlation coefficient. Okay, so for the background data are convert to z-score with a multiplied together. These products are then added, and the resulting sum is divided by n-1. Usually we're gonna there is formula to find the correlation coefficient, but in this class I'm gonna show you to compute by compute correlation coefficient by using StatCrunch later. Okay, so for example, the table below shows the height and weight of 6 women. We're gonna compute and interpret the correlation coefficient. So this is a table. You're gonna use a StatCrunch. Maybe I'm gonna use StatCrunch now. Let me see. So you're gonna get into my stat lab and then get into the course. You're gonna see in the left hand side here, there is a button named StatCrunch. Click on that. And then gonna click on here. Okay, and then you're gonna click open the StatCrunch. Right. Okay. So you need to input all the value from here. Okay, so let me copy. It doesn't. Okay, let me see. No, it doesn't. So okay, let me write. So this is actually, you know what? I just gonna put 61, 62, 63, 64, 66. Okay, 63, 64, 66, and then 68. And that's for the height. Change this one to the height. And this one is weight. So 104, 110, 104, 110, 141, 125, 141, 125, 170, 160. Okay, so that is the first step. You need to put all the data into the StatCrunch. Okay, now you're gonna click stat and regression and simple linear. Okay, so click on the stat, regression here, right, and then simple linear. Like that. Okay, so now you will see the x variable. You have to choose which one is x variable. Let's see. So usually I gonna because in here it doesn't matter because you don't see which one is depend on which one. So usually I'm gonna just choose say height is x and weight is y, or maybe I'm gonna check if the notes have that in the next page over here. Is it here? All right. Okay, so you can see that the height is the x-axis, the weight is y-axis. Okay, so let's come back with the height is x-axis, the weight is y-axis. Okay, so now let's come back with the StatCrunch. All right, so the x-axis is a height. So I put height. The y variable is weight. Okay, and then you need to see the next step. you're gonna just compute. Okay, so compute. All right, so now you can see the word correlation coefficient here. That's gonna give you 0.88093363, right? That's gonna be the correlation coefficient. Also, this one sorry, RSQ we actually is R square. When you take square of the correlation coefficient, you want to have this number. But anyway, for now, the main thing you look at is the R correlation coefficient. Okay, so now let's come back with the PowerPoint. Okay, so move to the next one. Okay, so in I'm gonna use slideshow. Okay, right here. So the stats crunch output will give you. Oh, so you see that. I also forgot to tell you. There's one more thing is. This is like a simple. This one. This all is output from the stat crunch, right? And this also the a line. This actually like a best fit line or model line that for the linear. It's actually if you present wage in here is y and height is x, then you can rewrite it as y equal to negative 4.2.88235 plus 9.02. Actually, I move a little bit. So I'm gonna round a little bit. So y equal to negative 442.88, and then plus with 9.03. I just round to 2 decimal number because I don't want to write too many things. And x, right? So you can see that is exactly like a linear equation in the mathematics. So like I write as a y equal to if you change it, like become like 9.03 x and minus 442.88. So it's exactly like mx plus b. And m in here, the slope in here is this guy, and the b in here is the negative 442.88. So StatScrum also helps you to have the best fit line or the model line for drawing in the graph of the association between wage and height in here. Okay, so so the next one is R correlation, right? And page 1 of the output has a lot of information, but we can see R equal to 0.881. Since R is close to 1, right? Is here you see R is close to 1, right? Close to 1. We will say there is a strong linear association between the height and the wage. Okay, so so there is a relationship between the height and the wage. See, you can see the correlation coefficient is close to 1, and it's go up here, right? It's positive, positive trend. All right, so let's move to the next page. And here, here in page number 2 is provide a graph of the data, including graph of the line that best fit the data. Okay, so let's we try to use Statistic to grab it to see. So I'm gonna move this over here. Actually, I think there's graph right here. Okay, perfect. All right. So here's a graph from the Statistic. If you you click on the button here and see the you're gonna see the graph of this. So the red line here is best fit line for this column, right? And you have like 6 samples, right? 1, 2, 3, 4, 5, 6, right? And yeah, you can see the line is going up and it's close to the strength is strong. So R in here has to be close to 0. Sorry, close to 1. All right. So let's move to the next one. Okay. What happened? Why I have this? Okay. So this is like for TI-84 calculator. You can use TI-84 to do this to find R. And I think also you can do by TI-83 if you have TI-83. I actually have only one software for TI-83 in my laptop. And let's see if I can open it for you to see. So TI-83. Right here. Oh, something is wrong. TI-83. Yeah, I have my I also have TI-84 software, but it's out of trial time. So there's only free TI-83 here. Okay. So in order to use TI-83, you're gonna firstly you have to put all the data number right here. Okay. So you may have to click. Oh, I have to put the list. So click on the start first here and click enter. All right. So you have L1. Let's say L1 is height. So this one is 61, 62, 63. Input all the number, right? 64, 66, and I think is anything 68, right? 68. Okay, the next one, arrow 2 here. The next one present for the weight. So I'm gonna have 104. Oops. 104. Delete 4. Enter. 110. 110. 141. 125. 170. And the last one is 160. Okay. After done, I will go to here. They didn't show you the steps to enter the data, but I just I'll show you. Okay. So now, you're gonna push stat. Okay. So stat again and calculate over here. Right. See. C, calc C. And then select option 8. Let's see, option 8. Linear regression A plus BX, right? See that? Enter it. So this will show you, and then enter it. It will show you A in here is the B from let me go back to the StatCrunch. Yes, see that? A in here, we're gonna be negative 442.88 here, right? And B in here is gonna be the slope, right? Which is 9.0294. See that? Right. Same. So so that just show you only finding the linear regression, finding the line on the stat, on the TIA4. So now let's move to the next one. And I recommend using StatGrant because that's really easier for you than using the TI-83 or 84. I think even TI-84, I think you can still use that on the Pearson website. I think they give you. Let me check if it have. Maybe here. I don't see it, but I heard that you also may have the TI things in this. So, okay, so let's come back with the lecture. Note about the correlation coefficient. So changing the order of the variable does not change the R. Okay, so is even so if I go back with the height and weight here, if instead of giving you instead of choosing height is X, I choose here's Y and here's X, then the R is still the same. Is still the same, right? It's still the same. Okay, so that's what they want to tell you in this page. Okay, so let's move to the next. And if adding a constant or multiplying by a positive constant do not affect R at all. So yeah, so when you're adding a constant or multiplying by a positive constant, it will not affect R. Okay. So next, and the R is unitness. Okay. So R is only useful to you to measure a linear change, and always graph your data first before computing R to make sure the association is linear, right? So when you graph the data first, you're gonna see the change is negative or positive. Is that going to be close to R, going to close to 0 or close to -1 or +1? Yes, just it's just that, right? You firstly have to grab the data first, and then you compute the R to make sure the association is linear. Okay, so I have finished session 4.2, and I'm gonna stop now. I will see you in the next section.